The last time you really laughed. The kind where you could not breathe, where your eyes watered and your stomach ached and you had to hold on to something. Your body was doing something that, if it happened for any other reason, would send you to a hospital. Your diaphragm was contracting in rapid bursts, roughly 5 times per second, each contraction generating an abdominal pressure spike comparable to a maximum effort crunch. Air was leaving your lungs at speeds approaching 70 miles per hour. Your vocal cords were being rhythmically slammed shut by the airflow pressure and forced open again. That is where the sound comes from. Each ha is a separate pressure wave. Your diaphragm recoils, air compresses against a partially closed airway, pressure exceeds the opening threshold of your glottis, and the burst escapes. Your intercostal muscles, the muscles between your ribs, were firing simultaneously, squeezing your chest cavity from the outside while your diaphragm drove pressure from below. Your heart rate jumped 10 to 20% in seconds. Your blood pressure spiked. Your abdominal muscles contracted harder and faster than they do during any exercise you would voluntarily choose. And then, within 30 seconds of stopping, something happened that no other physical exertion produces. Almost every vital sign in your body dropped below where it was before you started laughing. Lower heart rate, lower blood pressure, looser arteries, a wash of calm that settled through your chest and your shoulders and your face. Your body used the most violent voluntary act it is capable of to hit a reset button that 2 million years of evolution built and no pharmaceutical company has ever replicated. That reset is not a metaphor. It is measurable, specific, and physical. And every part of it, the violence, the recovery, the social architecture that triggers it, has a precise explanation in the physics of your body. Start inside the chest. Your diaphragm is a dome-shaped muscle that sits beneath your lungs, separating your thoracic cavity from your abdominal cavity. During normal breathing, it contracts gently, pulling downward roughly 1 to 2 centimeters, creating a pressure differential that draws air into your lungs at a calm, steady rate. During laughter, the contraction pattern changes completely. The diaphragm fires in rapid, forceful spasms, not the smooth, rhythmic pull of breathing, but a staccato series of violent jerks, each one driving the abdominal contents downward and compressing the air in your lungs upward against a partially closed glottis. The pressure inside your chest during a hard laugh can reach 50 to 100 centimeters of water pressure, comparable to a strong cough, enough to accelerate the escaping air to speeds that would register on a roadside speed gun. Meanwhile, the muscles surrounding the chest cavity are joining in. Your internal and external intercostals, 2 layers of muscle running between each pair of ribs, fire in alternating patterns, squeezing and releasing the rib cage in coordination with the diaphragmatic spasms. Your transversus abdominis, the deepest layer of abdominal muscle, the one that wraps around your torso like a corset, contracts forcefully, compressing the abdominal cavity and driving the diaphragm upward. Even your pelvic floor muscles contract during sustained laughter, which is why hard laughter occasionally produces urinary leakage. The pelvic floor, overwhelmed by the pressure generated above it, temporarily fails to maintain continence. This is not a sign of weakness. It is a sign of how much force the laughing body generates. The pressure wave that produces each ha travels through the entire trunk, from the pelvic floor to the throat, in a coordinated burst that engages more skeletal muscles simultaneously than almost any other voluntary act. No other voluntary activity recruits this many muscle groups in this pattern at this speed. Sneezing comes close, but you do not choose to sneeze. Coughing recruits similar muscles but at lower frequency and without the rhythmic repetition. Vomiting generates comparable abdominal pressures but is involuntary and deeply unpleasant. Laughter is the only act where your body generates these forces willingly, repeatedly, and with pleasure. Not all laughter generates these forces. In the 19th century, the French neurologist Guillaume Duchenne identified 2 types of smile, one that engages the muscles around the eyes and one that does not. The same distinction applies to laughter. Genuine laughter, Duchenne laughter, activates the orbicularis oculi, producing the characteristic eye crinkle, and engages the full diaphragmatic contraction pattern. Social or polite laughter, the kind you produce when your neighbor tells a wheat joke, typically does not engage the eye muscles or the deep abdominal contraction. It is produced by the voluntary facial motor system rather than the involuntary emotional motor system. The physiological reset that the rest of this script describes, the arterial dilation, the endorphin release, the cortisol suppression, occurs primarily with Duchenne laughter. The polite laugh is socially useful but physiologically shallow. The body knows the difference even if you do not. The reset requires the real thing, the kind where you lose control, where the diaphragm fires involuntarily, where the eye crinkle happens because it cannot be stopped. There is a secondary effect of the diaphragmatic violence that most people never learn about. Your vagus nerve, the longest cranial nerve in your body, running from your brainstem through your neck, across your chest, and into your abdomen, passes directly through the diaphragm. Every time your diaphragm contracts during a laugh, it mechanically stimulates the vagus nerve. Vagal stimulation activates the parasympathetic nervous system, the branch responsible for slowing heart rate, reducing blood pressure, promoting digestion, and shifting the body from alert mode to recovery mode. Clinical vagus nerve stimulators are used to treat depression and epilepsy. Your diaphragm does it for free, 5 times per second, every time you laugh hard enough to lose your breath. The mechanical violence of the laugh is simultaneously massaging the nerve that calms you down. Your nervous system classifies laughter as something worth doing. That classification has a reason, and the reason is in what happens to your cardiovascular system while the explosion is occurring. In 2005, Michael Miller, a cardiologist at the University of Maryland Medical Center, decided to measure exactly what laughter does to human arteries. His experiment was precise. Subjects watched 2 types of video content: comedy clips designed to produce laughter and stressful film scenes designed to produce anxiety. While Miller measured the diameter of their brachial artery, the major artery in the upper arm, using high-resolution ultrasound. The brachial artery is a standard measurement site in cardiovascular research because it responds to the same endothelial signals as the coronary arteries. What happens in your arm artery reflects what is happening in the arteries feeding your heart. During laughter, something specific happened at the cellular level inside the artery wall. The endothelium, the single layer of cells lining the interior of the vessel, released nitric oxide, a gas molecule that acts as a powerful vasodilator. Nitric oxide diffuses from the endothelial cells into the smooth muscle cells surrounding the artery and triggers them to relax. The artery widened. Miller measured an average dilation of roughly 22%. The inner diameter of the artery expanded by more than 1/5. This is approximately the same magnitude of dilation produced by 30 minutes of aerobic exercise. During the stressful clips, the opposite occurred. The arteries constricted by roughly 35%. The endothelium, under stress signaling from cortisol and norepinephrine, reduced nitric oxide production and released vasoconstrictive signals. The artery narrowed, blood flow resistance increased. The cardiovascular system shifted into a state that, if sustained chronically, contributes to hypertension, atherosclerosis, and heart disease. What drives the dilation is shear stress. When your heart rate spikes during laughter, blood flow velocity through your arteries increases. The faster moving blood exerts greater frictional force on the endothelial cells lining the vessel wall. These cells have mechanosensors that detect the increased shear stress and respond by producing nitric oxide, the same mechanism that produces vasodilation during exercise. The difference is that laughter achieves the heart rate spike in seconds rather than minutes, and the spike is followed by a sharper parasympathetic rebound than steady-state exercise typically produces. Miller's numbers frame the scale, the difference between the laughing state and the stressed state. A swing of roughly 57 percentage points in arterial diameter is larger than the difference between sitting still and going for a run. Miller published the results in the journal Heart and noted that the vascular response to laughter was comparable to the benefit of aerobic exercise or statin medication. A 15-second laugh produced an arterial response that overlaps with the effect of a drug designed to be taken daily for years. You see, this is where the physics becomes personal. The warm, loose feeling you have after a really good laugh? The sense that something has released in your chest and your shoulders and your face? That is not an emotion. It is your cardiovascular system entering post-exertion recovery. Your heart rate drops below baseline. Your blood pressure settles lower than it was before you started. The parasympathetic nervous system activates more strongly than usual, as if the intensity of the exertion demanded a proportionally stronger wind down. Your body treats the laugh as a workout and grants you a recovery phase. I find this remarkable. The relaxation you feel after a hard laugh is not psychological. It is hemodynamic, measurable in the diameter of your arteries, the rate of your heartbeat, the tone of your vascular smooth muscle. The laugh earned it the same way a run earns it, except the laugh took 15 seconds and the run takes 30 minutes. For someone over 65, someone whose arterial walls have stiffened with decades of use, whose endothelial function has declined, whose nitric oxide production is lower than it was at 30, the Miller effect is not trivial. The 22% dilation he measured represents a temporary restoration of vascular flexibility that the aging artery produces less and less on its own. Every genuine laugh is a brief return to younger arterial behavior, not a cure, not a reversal. A moment of the physics running the way it used to run. Now, laughter does something else to your body that has nothing to do with your arteries, and it explains why your stomach hurts after you have been laughing hard. Robin Dunbar, an evolutionary psychologist at Oxford, designed an experiment to test a specific hypothesis. Does laughing physically change your pain threshold? Not your emotional response to pain, but the point at which a stimulus crosses from pressure into pain? Subjects had a blood pressure cuff inflated to the point of discomfort, or a frozen wine cooling sleeve pressed against their skin, and the time they could tolerate it was recorded before and after watching comedy. The subjects who laughed, genuinely laughed, hard enough that the diaphragm and abdominal muscles engaged, showed a consistent increase in pain tolerance of roughly 10%. In pain research, a 10% threshold change from a non-pharmacological intervention is clinically significant. The subjects who watched content they found interesting but not funny showed no change. The effect was specific to the physical act of laughing. Here is the mechanism. When your diaphragm and abdominal muscles contract hard enough and long enough, your body interprets the exertion as significant muscular work. It does not know you are laughing. It felt rapid, forceful contractions across the abdomen, the intercostals, the muscles of the pelvic floor, and it responded the way it always responds to intense muscular exertion, by releasing beta endorphins, opioid peptides that bind to the same receptors in your brain and spinal cord that morphine binds to. The ache in your stomach after a hard laugh is proof the exertion was real. Your abdominal muscles performed the equivalent of dozens of high-speed crunches in under a minute, and your nervous system responded with a chemical reward that reduces pain sensitivity across your entire body. What this means? Your body gave you painkillers because you laughed. It could not tell the difference between laughing and exercise. The muscles contracted, the threshold was crossed, the endorphins released, the same system, the same molecules, the same receptors, activated by an act that feels nothing like a workout, but registers as one in every muscle it recruits. Dunbar found something else that becomes critical later in this story. The endorphin effect was significantly stronger when people laughed in groups than when they laughed alone. The same comedy material, the same physical act, but the neurochemical payoff was amplified by the presence of other people. Group laughter produced more endorphin release per minute than solitary laughter. The social context changed the chemistry. Remember that? It matters. In 1989, something unexpected showed up in blood work drawn from people who had been laughing for an hour. Lee Burke, working at Loma Linda University, had subjects watch 60 minutes of comedy while he drew blood samples at intervals. The results went beyond cardiovascular and pain effects. Subjects showed measurable increases in natural killer cell activity, the immune cells that patrol your body continuously, identifying virus-infected cells and early-stage cancer cells before they can establish themselves. they showed increases in immunoglobulin A, the antibody lining your respiratory and digestive tracts as a first barrier against infection, and they showed significant decreases in cortisol, the stress hormone that your adrenal glands produce in response to perceived threat. Cortisol is worth understanding in detail because its chronic elevation is implicated in nearly every condition associated with aging. When cortisol stays high, as it does under sustained stress, poor sleep, chronic pain, social isolation, or the background anxiety that accumulates across a lifetime, it suppresses immune surveillance, the very system that catches early cancer cells and viral infections. It promotes visceral fat accumulation around the organs. It impairs memory consolidation in the hippocampus, the structure that converts daily experience into lasting memory. It accelerates arterial stiffening. It disrupts sleep architecture. It interferes with wound healing. The list of downstream effects reads like a catalog of age-related decline, because chronic cortisol elevation is one of the mechanisms through which stress accelerates the aging process. Laughter suppresses cortisol. Burke's measurements showed the suppression beginning during the laughter and persisting for 12 to 24 hours afterward. A separate study by Keiko Hayashi at the University of Tsukuba found that laughter after a meal significantly reduced post-meal blood glucose spikes in subjects with type 2 diabetes, the muscular exertion increasing glucose uptake by skeletal muscle, the cortisol reduction improving insulin sensitivity. For someone over 65, whose cortisol baseline may already be elevated by decades of cumulative stress, regular laughter is not a luxury. It is a physiological counterweight to one of the most damaging chronic conditions in aging biology. That is what laughter does to your body: the cardiovascular dilation, the endorphin release, the immune activation, the cortisol suppression, the metabolic reset. The question is, why evolution built something this medically powerful and made it feel like fun? The answer changes what you think laughter is. Human laughter is acoustically unusual. Most vocalizations you produce, speech, singing, humming, crying, are made by controlled modulation of airflow across the vocal cords. Laughter is different. It is produced by a series of uncontrolled pressure bursts. Each ha is an explosive release of compressed air through a glottis being forced open against its own muscular closure. The fundamental frequency typically falls between 150 Hz, but the harmonic structure is chaotic, rich in overtones, irregular in spacing, with amplitude variations that follow no predictable pattern. Your auditory cortex can identify laughter from a recording within a fraction of a second, faster than it identifies speech content, faster than it identifies the speaker's voice. The brain has a dedicated processing pathway for laughter recognition, separate from the language pathway. Chimpanzees laugh, gorillas laugh, orangutans and bonobos laugh. Their laughter sounds different from yours, breathier, more panting, produced only during exhalation rather than the alternating pattern of human laughter. But the acoustic structure is recognizably related. Jacques Panksepp, a neuroscientist who studied the neural basis of emotion, demonstrated that even rats produce ultrasonic vocalizations during social play that share functional characteristics with primate laughter. They occur during positive social interaction. They are contagious between individuals, and they are associated with the same dopaminergic reward pathways. Neural circuits that produce and detect laughter were in place in the common ancestor of all great apes, at least 14 million years ago, millions of years before the first human word was spoken. Laughter is older than language, older than fire, older than stone tools. When you hear someone laugh across a crowded room and your face begins configuring its own laugh before you know what was funny, you are running neural software that predates every other social signal your species has developed. The laugh was there before the word. The bond it creates was there before the sentence that might describe it. You are roughly 30 times more likely to laugh when you are with someone else than when you are alone. 30 times. That number comes from Robert Provine, a neuroscientist at the University of Maryland, Baltimore County, who spent years recording naturally occurring laughter in everyday settings, shopping malls, sidewalks, office conversations, dinner tables. He did not study comedy. He studied people talking. He recorded thousands of laughs in their natural context and found two results that fundamentally reshape what laughter actually is. Provine's 30-to-1 ratio is not about humor availability. Funny content exists on your phone, on your television, in books. The ratio exists because laughter is not primarily a response to humor. It is a social behavior. Its trigger is not comedy. It is company. Provine's other finding changes the picture entirely. Most laughter in natural conversation does not follow jokes. It follows ordinary, unremarkable sentences. Someone says, "I will see you later," and the other person laughs. Someone says, "It took me 20 minutes to find parking," and both people laugh. Provine analyzed the content preceding naturally occurring laughs and found that fewer than 20% followed anything that would qualify as humorous by any standard. The other 80% followed routine social exchanges, greetings, observations, small talk, the unremarkable sentences that fill the space between people who are comfortable together. You have experienced this. You have laughed at dinner when nothing funny was said, when someone told a story you have heard before, when someone made an observation about the weather, when someone repeated something ordinary with a particular timing that triggered a response you did not plan. That was not a humor response. That was your bonding circuitry firing, a physical broadcast that communicated, "I am with you, I am comfortable, we are connected." The content was irrelevant. The connection was the point. Laughter spreads through a room because each laugh lowers the activation threshold for the next person's, a contagion effect that operates through the mirror neuron system. Laugh tracks on television work despite everyone knowing they are artificial, because the auditory signal of laughter triggers the neural preparation regardless of whether the source is real. The social circuitry does not check for authenticity, it responds to the sound. This is why you laugh differently with people you trust than with strangers. The laughter is looser, longer, more abandoned, because the bonding signal is stronger when the relationship is deeper. This is why Dunbar's group laughter effect was stronger than solitary laughter. The social dimension amplifies the physiological one. Research by Madan Kataria showed that even voluntary, deliberate group laughter, no jokes, no comedy, transitions into genuine Duchenne laughter within minutes and produces the same physiological reset. The body responds to the contraction pattern, not to the reason for it. And this is why the loss of close relationships has a physical consequence that extends far beyond grief. Something happens in your brain the moment it hears someone else laughing. Mirror neurons in your premotor cortex fire in response. 15 facial muscles begin configuring. The zygomatic major pulling the corners of your mouth upward. The orbicularis oculi crinkling the skin around your eyes. The risorius pulling the lips laterally. The preparation begins in milliseconds, before conscious evaluation. You do not decide to laugh. Your social circuitry decides for you. This is why you have laughed at things that were not funny, in meetings, at funerals, in moments of terrible timing. The laugh was a social reflex executed by a pathway older than language itself. There is a number worth knowing here. A child laughs roughly 300 to 400 times per day. An adult over 60 laughs roughly 15 to 20 times per day. That decline is not entirely about social isolation or the loss of novelty, though both contribute. Part of it is neurological. As the prefrontal cortex matures and strengthens its inhibitory control over the emotional motor system, the threshold for triggering involuntary laughter rises. Children laugh easily because the circuitry that suppresses involuntary responses is not yet fully developed. Adults laugh less because the brake is stronger. By 65, the brake has had decades of reinforcement, decades of social context where suppressing laughter was appropriate, where emotional restraint was expected, where the involuntary motor pathway learned to defer to the voluntary one. The Duchenne laugh, the full diaphragmatic, eye-crinkling, vagus-stimulating reset, requires that the brake fail. It requires the involuntary system to override the voluntary one. That is what losing control means. When your social world shrinks on top of that, when the people who could bypass the brake move away or retire or die, or when the circumstances of your life reduce the number of people you see regularly, the two effects compound. The neurological threshold rises with age. The social triggers decrease with circumstance. If you are over 65 and you have noticed that you laugh less than you used to, both forces are working against you simultaneously. And with them go the cardiovascular resets, the endorphin releases, the cortisol suppressions, the arterial dilations that each laugh delivered. You lose a full system physical intervention that no prescription medication replaces. Not because the medication does not exist, but because the combination of cardiovascular exertion, vagal stimulation, nitric oxide release, endorphin production, cortisol suppression, immune activation, and social bonding neurochemistry that a single 15-second laugh produces has never been replicated by any single compound. The engineering is too integrated. The systems involved are too many. Your body already knows which systems to activate and in what sequence and at what intensity. It is known for 2 million years. It just needs the trigger. A body that laughs regularly and a body that does not are running different physiological programs, different cardiovascular profiles, different immune baselines, different cortisol levels. The difference is measurable. The mechanism is physical. The trigger requires the presence of other people to fire at full strength. If your social circle has gotten smaller in recent years, your body has noticed. Not emotionally, physiologically. The prescription is not complicated. Find someone who makes you laugh. Genuinely laugh, the kind that defeats the break, and see them regularly. The people who make you laugh hardest are not just entertaining you. They are defeating a neurological inhibition that strengthens with every year of adult life. Your cardiovascular system does not care whether the conversation is profound. It cares whether your diaphragm fires. The next time you laugh, really laugh, the kind that takes your breath and leaves you holding your ribs, you will know what your body is actually doing. Your diaphragm is firing like a piston. Your vagus nerve is being massaged into calming you down by the same contractions that are driving air out of your lungs at highway speed. Your arteries are opening wider than they would during a jog. And endorphins are flooding your system from muscle exertion your body cannot distinguish from exercise. Within 30 seconds of stopping, every system will settle into a state that is measurably, physically better than where it started. That is not joy. That is not amusement. That is a 2-million-year-old full system reset. Cardiovascular, respiratory, immunological, neurochemical, metabolic. Built by evolution, triggered by social connection, disguised as the best feeling your body knows how to produce. The violence is the mechanism. The pleasure is the incentive. The social trigger ensures it happens most often in the presence of others, where the survival benefit of bonded groups amplifies the individual benefit of the physiological reset. And the dose is 15 seconds of losing control in the presence of someone who makes you lose it. Your body has been waiting for the next one since the last one ended.